For the first time we have measured the rotation of an extrasolar planet around its axis. For this planet, Beta Pictoris b, ESO's VLT has measured its length of day to be about 8 hours. This is an important step because it tells us something about how planets like Earth are formed.
Imagine, this is Beta Pictoris, a very nearby star, and around it is Beta Pictoris b. What we found is that it's rotating very fast around its spin axis, much faster than Jupiter. In our own solar system we find that the heavier the planet gets, the faster it rotates. This planet is both bigger and heavier than Jupiter, and it indeed rotates faster around its spin axis. And now it's interesting to see whether this trend holds for every solar system in our galaxy. So how do we actually measure the rotation of this planet? For this is not only sufficient to make an image of this planet, but we have to measure the spectrum of the light that's coming from the planet. From sound waves we know that when something is moving towards you, the sound has a higher frequency, and when something is moving away from you, it has a lower frequency. Exactly the same goes for light. When a planet is rotating, part of it is moving towards you and the other part is moving away from you. And by measuring both this high frequency from one side and the lower frequency from the other side, we can detect the rotation of the planet. What's so special about this technique is that in the future we can actually make a map of this world.
As we look further ahead, the NWO PEPSci network will play an important role. In this network, astrophysicists and Earth scientists work together on questions about how small rocky planets are formed. In the near future, the ELT telescope may even probe such planets in the habitable zones of nearby stars and look for evidence of life.